This video is going to be on an application of ratios dealing with what we call age dependency ratios in the global world. So you will see here on the right, we have ourselves a beautiful graphic. Notice that these numbers are in thousands. So really every one of these should have 3 more zeros added to the end of it. Okay, and then we have this piece over here. And these are the totals. So 0 from 14 years, that's these 3 added together. 15 to 65, 64 is here, and then the last piece. Why this matters, 0 to 14 are considered children, 15 to 64 are considered working class, and 65 and older are considered old. Okay, that's kind of the definitions for age dependency ratios. So that right there was the relationship between the two tables. Are these exact values or estimates? Now think about this. Now for one, they're from 2011. There's one thing. But two, this is a census. So think about how a census is done, right? Surveys are sent out to families, people fill them out, send them back in, and then people die and people have babies, and some people don't fill them out, and some people are homeless. And therefore, they have to be estimates because there's no way these can be exact values with all the different things that go into this. And the U.S. population, well, that would be all ages. So that's this number, 306,108. But remember, we're in thousands, so we're going to add 3 more zeros. So the U.S. population in 2011 was roughly 306,108,000. Let's move on to some problems. And hopefully you have this next to you. I'm not necessarily going to flip back and forth. But we're going to first calculate the under 15 to the total. Okay, so under 15, that's the 0 to 14 to the total population. Now, as soon as you write total on the bottom, you know this is a part to whole ratio, which means I can write this as a percent. So just remember, here's our total, 0 to 14. So I end up with 62,155 over my total. Ooh, that's a 2. I don't want a 2. I want a 3. Whoops. 306,108. That fraction as written is meaningless, but again, we have a part to whole ratio, so I can change this to a percent. So I'm going to go ahead and change it first to a decimal by dividing, numerator divided by the denominator, and that gives me 20.3%. So interpretation, 20.3% of the 2011 U.S. population were children. So roughly 1 in 5, because that would have been 20%. Okay. Now let's talk about the child dependency ratio. Child dependency is calculated by taking the children divided by the working class. So we're going to take the 0 to 14 and divide it by the 15 to 64. This is part to part because both of these are part of the population, which means we have to write our answer as a decimal. We cannot write it as a percent. So that's kind of big of how it's different from number 4, is that we're dealing with part to part. So I still have my 62,155. And now I'm going to the working class, which is 204,775. I changed that to a decimal, and I'm going to go 4 places, but I went around to the nearest thousandths, 5 rounds up, so this is 0.304. Now, what does this mean? Well, if I put this over 1, this represents children. I can't type, write, whatever I'm doing, and these are the workers. So that means there are 0.3 children dependent on every 1 worker. Now, a lot of people have trouble saying 0.3 of a child. That doesn't make any sense. So let's look at this. If I have 0.3 over 1, mathematically, I can multiply the top and the bottom by 10, which moves my decimals, and that gives me 3 over 10. So now I have 3 children dependent on every 10 workers. Or I could move it again, multiply by 10 again, and I get 30 children are dependent on every 100 workers. I mean, I could keep doing this as much as I want. Or 300 children are dependent on 1,000 workers. Those 4 ratios are all equivalent. And so how is it different? This is part to part, whereas in number 4 we were talking about part to whole. And remember, with part to part ratios, we only write them as decimals. All right, so now we're going to talk about old people. Old age dependencies. So now we're talking about oldies to the workers. All age dependency ratios are compared to workers. So how many old people we have? Well, if you go back to that first page, we have 39,178 old people, and our working class is 204,775. So as a decimal, we're at 0.191. Again, over 1. So the top number represents the old people, and the bottom represents the workers. Again, part to part, because old people and workers are both part of the population, and therefore we have to keep it as a decimal. So what does this mean? Oh, look at that, I already calculated it. It means that there are, okay, so if I take 0.191, I'm going to go ahead and round that to 0.2. Be careful if you're doing your homework how you round it, but this is like 0.2 old people dependent on every one, it's a 0, every one worker. Again, but then we can say, so if we have that doesn't work, that's a bad color, 0.2 over 1, if we move our decimals, that gives us, the decimal goes there, 2 to 10, or 20 to 100, or 200 over 1,000. So the top number represents how many old people are dependent on the bottom number of workers. And the last one here is age dependency. Now, age dependency means we're talking about all people who are considered dependents. So we have children plus old people. These are all of the dependents. That looks horrible. Let me write that a little nicer. 101,333. So this is how many total dependents we have. So age dependency is the number of dependents over the number of workers. Again, this is part to part, because dependents are part of the population, workers are part of the population. So when I'm calculating this, I put my total dependents over my total workers, and that gives me a dependency ratio of 0.495. So therefore, there are 0.495 dependents on each worker. And there's your interpretation of the age dependency ratio. Now, in general, which one is more economically desirable, a high age dependency ratio or a low one? Well, low. Because then we have more money in the, free flowing in the economy. Think about this in terms of your world. Okay, I am single, I have no children. So when I get a paycheck, I pay my bills, and then the rest of the money I can spend on shoes, a new phone, a new watch, because I don't have to take care of kids. I only have one mouth to feed, and that's mine. But if you are married and you have 4 kids and you're living on a single income, think about, you don't have extra money to go buy a new watch or new shoes all the time, because you're feeding your family. You're buying, you're doing things that need to happen for your children. So the lower the number, the less people you are supporting, the more free-flowing money in the economy. So if we're talking about for the economy, we want a low dependency ratio so that there's more free-flowing money.